Radicals and fractional exponents. We're going to look for some patterns here. So in this first question, what is the index? Well, remember we looked for the index right in here, and if there's not an index, then the index is a 2. What is the radicand? Remember that we find the radicand under the radical, so our radicand is x. Base, remember the base is the value that holds the exponent, so our base is x. And what's the denominator of the fraction that we have? Well, our exponent is a fraction, and that denominator is a 2. Let's try again. In this question over here, again, we're looking for the index, which is right here. So our index is a 3. That's terrible. Let's try again with that. Index is a 3. Then I want to look over at the other side at the fraction, and the denominator of our exponent is also a 3. Then I want to look for that radicand, and our radicand is under here at 5. And then what is our base number on the other side? Our base number is a 5. Are you looking for a pattern here? Let's try one more time on the other side. So here again, I want to look for first the index. So my index is up here at 5. So I have an index of 5. And what is the value of the exponent denominator? Is a 5. So what I notice here is that the index and the denominator end up being the same. So as we work back and forth, we'll have to think about that. I'm looking for my radicand. My radicand is under here at 4. And my base right here, also at 4. So the base and the radicand are the same thing. So I'm going to let you practice a couple of questions. Let's look for some more patterns. Again, let's use the same questions. So first of all, what's my base? Base is here, so my base is x. What's your radicand for this question? Well, in this question, a little bit different than before, but my radicand is here at x squared, but notice they are sharing the x piece. This will become important. My index is 3, and the denominator for my exponent is also 3. So now if we look what's missing, notice that 2 piece. So that 2 is found here in the numerator. It's also the exponent on my radicand. Let's try again. So looking here, let's look for what we've got. So what we're looking for here is the fact that we have an index of 4 equals the exponent denominator which is also 4. Then I've got the radicand exponent of 2 equals the exponent numerator of 2, and we have the base of the radicand 5 equals the base on the other side. One more time, looking over here, I've got my index matching my denominator. I've got my base matching my radicand. So this is how these things are equal to each other. Now I'm going to give you some practice in rewriting. Now we're going to find out, is one value the same as another? So is the cube root of 16 equal to 16 to the 1/3 power? Well, I could do this in the calculator. So in the calculator, let me erase that and go back to a regular pen. The cube root of 16, if I go in the calculator, is 2.52 approximately. In the calculator, 16 to the 1/3 power is also 2.52. Okay, so calculator tells us yes, but we've got to think too about those times when a calculator won't do it for us. But remember the idea from the previous slides, that because we have an index matching a denominator, and we know that our radicand matches our base, that tells us that yes, these are equal. And that's what you're going to have to be able to prove as you test over this. Is 16 to the 3/2 equal to 8 to the 2nd power? Again, I could use a calculator, but you're going to be required to show how you know this works or doesn't work. So here, I need to remember how this is written. So remember that the base becomes the radicand. So this base number became my radicand. Remember that that index is the denominator, so that 2 we know goes here, even though with square root we usually don't write it. And finally, that numerator piece becomes the exponent. So what I have over here is the square root of 16 times 16 times 16. So we can pull out, because it's square roots, we pull out in pairs. So I'm going to pull out this pair of 16. The square root of 16 is equal to 4. So I'm left with 16 times 4, which equals 64. I know this seems like a lot of work, but this is how you're going to have to show that you actually understand this. On the other side, I need to remember that 8 squared is 8 times 8, which does equal 64. So in answer to the question, we would say yes. Now I'm going to give you a little time to practice this. So in conclusion, as we work with radicals and fractional exponents, we can go back and forth between the two. So if I have 8 to the 2/3 power, remember that that base becomes the radicand, the denominator becomes the index, and the numerator stays as an exponent. If I were to give you the 4th root of x, y to the 3rd power, I could rewrite that taking the base part of the radicand. The exponent of the radicand becomes a numerator, and the index becomes the denominator.